I got marketing.
I'll send you, well, this is where the opening question's playing. I'll send you an email and I'll help you out. All right. So for today, here's what's going to go on. We're mostly going to be doing a lab. So when I say mostly going to be doing a lab, I have to give you the same intro stuff that I usually give you. Okay? So up on my desk is the car that I made. Do you guys remember those blue cars I gave you before?
Yeah.
So those, and like if you're not a car person, it doesn't really matter. They have a weird center of mass, and they're actually too massive to go any measurable distance with the rubber bands. The one that I made for you guys is a lot thinner and a lot lighter in hopes that you'll be able to actually measure something. So as a class, we're going to go through what you should have is your setup, like your variables, your hypothesis, all that kind of stuff. And then we're going to do, up on the board, we're going to do this part together. Because I'm just telling you right now, if you don't change your grams, which is what's on here, to kilograms, you end up some very funky numbers that look very weird on a graph. And then you're all Debbie Downer because your graph looks weird. In groups, which most of you guys are going to be able to be in pairs, today, you guys are going to collect your data. And I will tell you right now, your data is probably easier, and I know some people are a little bit squeamish about being on the floor. It is easier to have the car kind of roll on the floor, but if you look where I'm standing, do you guys see that there's like a, I don't know, continental divide right here? Like, even this kind of like, there's a big hump in the tile. Even this is going to make a difference, so pick some kind of like smooth spot. So what's basically going to happen is you're going to tell me who you're going to be paired up with, and then when I give you guys a bucket, or I don't know, basket, you guys are pretty much going to have runways. So do me a favor, look over by my window. Other than that basket, the other thing that you guys are going to need are 2 meter sticks that are going to kind of work as your lane. So when I say work as your lane, I would like to tell you that the whatever cars I made have perfect alignment. They don't. All right, listen, I'm not the best super gluer in the world, but you will at least get it to go straight enough that your velocity and your speed you can use interchangeably.
Your tires fit.
No.
Oh my goodness, that'd be a very bad lab if they didn't. Yes. So they
Make sure
they spin into so they have a straw that is inside of the axle, right? So it is like double axle. So once you're done collecting the data, then you guys are going to work on some calculations. I'm going to tell you right now, I'm going to kind of show you what the calculations look like, but it is rainbow bright just like it was for the other one. As long as you can follow the colors, you can pretty much figure out what is supposed to go where. So here's the thing. This is a very, I don't know, I think it's maybe like 3 minutes, but it is a very good illustration of Rube Goldberg's machines. So that is a big fancy name that you don't need to know right now. When you get to physics in high school, you're going to have to make one. So in your mind, and I know this seems like a silly thing to say, think about which part of this video you would probably be able to do like in this room or at your house, and which one they definitely needed to do in a sound studio. Out of the whole video though, how many do you need? Just how many? How many is the question asking for?
3.
3, okay? So you're gonna see, I don't know, I think someone counted the one time and said there was 85 action pairs. You only need 3 of them, okay? And there's the closing question. So, for this, the first couple seconds, there's no music. Does it say what you done?
Oh. Wow. Never heard of it.
Wow.
Were you the one?
I can hear dolphin noises.
There we go. That's all crazy.
So you can obviously tell right about like, I don't know, here-ish. Was this their first time going through it?
No.
No, not even
Sitting
close.
in the back.
Yeah, so if you look at that, and then whenever they were talking about like the TV thing, or not talking about it, whenever they had the TVs being smashed, the fact that you can see like behind them all those TVs. So the other thing that this has won some like science awards, because the other thing is, if you know anything about like being continuous shot, like in order for this to work, it was one continuous shot. So it's not like they followed the same object, they followed the momentum of the system, meaning they followed the one thing that was moving, right? So it kept on going from one thing to another. So I'm not trying to even like make fun of this video, but have any of you ever seen a TV like that? Like the old. Yeah. So like I'm not kidding. When you go out by like Northside Pool, that one electronics store, and a lot of like electronic refurbishing, a lot of those electronic places won't even take those kind of TVs anymore. Are they very heavy or very light? Very heavy, right? So a lot of places won't even take them to recycle them anymore because they are that bulky and they're that kind of like dated. So we, however, are not going to smash them in school, because even if I did have a whole bunch of extra TVs, when that sledgehammer hits it, what goes? Line. Yeah, you got glass, right? That's part of the reason why that TV is so heavy, is because that front plate is glass. So for like safety purposes, we're not doing that. But what is one object that they use that we would definitely have in the school?
Fire truck.
So the bowling balls are like toy fire trucks. We have those. So at the very beginning, that little truck, it just moved a cute little set of what? Dominoes, right? So one action reaction pair, we could say like the truck knocked down the dominoes. This one I'm okay if it's not a whole sentence. So a truck knocked down dominoes. What was happening here? What was the action? The hammer swinging did what? Smashed the TV or broke the TV? I don't know. Any other ones? I won't lie. It's one of those things like when you watch it, like a first, and I'm not going to make you watch the thing again, but when you talk about trying to watch it, even like them getting sprayed with paint, or even like little marbles moving like that, if you talk about being able to have momentum in the system, part of the reason why there's no music going on in the video, even before there was music, there was sound. That sound is being lost to the system. It is wasting energy. So all the little clink, clank, blow up things that you heard, that proves that this is not a closed system. Energy is continuously being wasted. So when you talk about being wasted, anytime you hear it, it is energy being used that we aren't actually using. So even if you talk about a tire rolling to turn on lights, or the blow-up machine, or a fan turning on to move an umbrella, any one of those can be your third ones, okay? I don't have enough time to set up a Lego city like that just to have a truck full. All right, everyone got their 3 pairs? Good? Okay, so do me a favor, guys. In your Schoology, if you can open up your Newton's Car Lab. And if you have trouble finding it, there's a new folder. I think I made it black for you guys. There's a new folder that's called Applied Forces. Next week, we're going to be talking about pressure and work and all that kind of stuff. So those are using Newton's forces. So this week, we did 2 labs. So now, I'm not saying we're going to do 2 labs every week, but this section is more like the doing of all the laws that you've learned about before. So either in your calendar over here for Monday, or in this black folder, you should only have one thing that says Newton's Car Law Lab.
That looks fun.
So here's the thing. This lab should be done with a balloon on the back of the car. Like if you ever look this up online, it has a car, and in the back of the car, you blow up the balloon, and then the balloon is what actually makes the car go. However, we're not going to do that. Okay? Instead, this is what your car is going to look like. Now, the part that Miss Myers worries about, I'm not kidding. Not even kidding at all. This is my biggest fear. As 8th graders, I need you to make sure you are still being responsible. Like, I get that you're only in 8th grade, but you are in 8th grade. So I am gonna give you 3 rubber bands. This rubber band is very, very cool because it is like when it stretches, it's like really. Can you do me a favor? Can you get that big rubber band out of any one of the bins? Just go like that. Yeah, so it's pretty cool. Okay. Here's what it is not. It is not a, oh man, let's make the best football day ever. It is not a, oh man, how big of a welt can I leave in my friend's arm? I'm just telling you right now, because I'll just be very honest. I have no time to give you detention. There's no after school bus. So my whatever thing is that you're just probably done up with a day of ISS. Okay? Like, what's wrong? What? Okay, then stop. So here's the thing. Like, I am just asking / telling you, you need to be responsible with the rubber bands. That's the largest one, so since you can pull it back the furthest, when you actually have it hit your little bumper back here, it's probably going to go the wettest. The furthest, right? So here's the thing. When you talk about furthest, and then 2 of you said fastest, both of you are right, or faster. So up in that picture, or in this picture, that's all you have to remember, all right? The action is, and I know this seems dumb, but is the action the first or the second thing? Yeah, that's the first thing you got to do. If you guys know where this is in my room, I set it up right over there. That was super dumb because this was actually facing like this desk right here. So if I hit it, it would just smack my desk and do what? Bounce back. However, the other rubber band you're going to get 3 sizes of rubber bands. The other one is like, oh, so cute and so little, okay? That one is going to be obnoxious because when it goes, it's probably going to go like this far, and that's what you have to measure, okay? So if you go down to your research, I filled it out for you, okay? So for your research, we're talking about 3 basic principles, okay? So the 3 basic principles you're going to be looking at today is that momentum is the quantity of how much inertia a dynamic object has acting upon it. Which I know sounds super fancy, but it's not. It just means, oh my goodness, things are going to move today and you're going to measure them. That's it. It's fancy. So the total momentum in a closed system is constant. So here's, and again, not making fun of the lab, definitely not making fun of you. But as you go through the lab, start thinking about why this is not a closed system. Why is this not a perfect system? Your energy in will never be equal to your energy out. But the whole point of today is the idea that momentum actually means something is moving that has power behind it. So if you remember last week when you guys had, or no, was that Monday? You guys did the 2 marble thing in the golf ball? Was that Monday? I think it was Monday, yeah. So that whole lab, when you guys went down the ramp, that thing, you had to measure the mass of each of those, and they changed. Now, your one constant is going to be mass. So here's the thing. If this is your formula, on Monday, you messed with the mass. Today, you're going to mess with velocity. So that means, so if you're going to mess with the velocity, that means in that bin, aside from rubber bands and aside from a car, what else has to be in there? Stopwatch, right? So you are going to be doing a lot of timing today. And I will tell you, this has to be a coordinated effort between you and your partner. So when you talk about your variables, your independent one, the one that you are going to get to change, is the acceleration from force of the rubber band. You are going to get to pick to do the small, medium, or large. Well, I gave you an order. You don't have to necessarily do it in that order. Your dependent variable, the thing you're going to be measuring, is how much momentum it has. How far does it actually end up going? So when you are done, you're going to end up with, hopefully, a graph that has 2 lines that more or less go like this. They might kind of creep down, but the thing of it is they should definitely both have a positive correlation. Meaning the longer you make your rubber band, the more force and the more momentum your car had. So, since you only have one car and you're not changing your car, what does that mean it is in the experiment? It's the one thing what's the third type of variable we have here? Control, yeah. So the control variable is going to be your mass of the car. So that's why we're going to put that in together to make sure that we're all good. Oh my gosh, you okay, Angie? Yeah. Okay. To make sure that we're all good about changing grams into kilograms. So here's the thing. In your mind, you need to start to be able to pull these three variables out to make your own hypothesis. So everybody, anybody, you always start your hypothesis with what keyword? If. So if what are you going to be changing? Yeah, the force from your rubber bands, okay? So, are we done with these three?
Oh, yeah.
Hayden? Okay. So here's the last piece that I'm going to have you guys fill out together. So if the car has more acceleration due to a greater force, then it will have a higher momentum because every action has an equal and opposite reaction. So you pull the rubber band to the left, the car moves to the right. You pull the rubber band far back to the left, the car should move far to the right. So aside from because I won't lie, like Ms. Myers putting together lab, it's a very valid question to ask, does a tire spin? So if you talk about not being able to move very well, that might be one of your sources of error. Inside your chassis, so like you have two axles and you got a little chassis that I try to make as like straight on there as possible. Most of them, your axle can kind of wiggle within the car, okay? So understand that's a good thing because that will let your tires freely rotate. However, that will also kind of increase the likelihood of it like kind of trying to veer off a little bit. So, in your car, if you look at your procedure, the first thing you're going to do, look at number 1, is measure the size of your 3 what's. Look at the part in brown. Hover over the band. So here's what's going to happen. This is what I want, okay? I want the distance from where, like when you hold it like that, like I had in the picture, from this part to where your finger is, okay? So that is the length that you are measuring. Does that make sense? What's wrong? Okay. Yeah, yep. So you want to make a triangle. I will tell you, it makes a difference whether or not your triangle looks like this or looks like this. If I were you and your partner might want to do a little bit of like figuring out. And I'm okay if you do a couple of test runs because you need to make sure you hit it dead on this bumper. In reality, can you hold on to the bumper like I'm holding on to it? No, right? Because it's not going to go anywhere. I mean, you could, but then your car's not going to move. So, the thing of it is, you guys might want to do a little bit of adjusting to see how far it goes. If it snaps, here's the deal. You only get a new rubber band if you give Miss Myers the old rubber band. In order for you to leave my class today, I have to see that your bin, or Miss Brown has to see that your bin has all 3 rubber bands in it. I know it sounds silly. Miss Myers didn't get in trouble because one of you want to take one of my rubber bands. Here's the part though. Look at step number 1. The size of your rubber band is going all the way down in which data table? Yeah, data table number what, guys? 2. So do me a favor, right now, scroll down to your second data table. Oh my God, it's so many colors. There you go. So here's the thing. So not making fun of anybody who doesn't get algebra, but the size of your rubber bands, if you look on your data table, is in what color? Brown, okay? That is just kind of help you in your mind look at the directions and go back to what you're supposed to do. If I tell you to look at the average acceleration, look at your data, just look at this one. What color is it supposed to be? Orange. So here's the thing. If you look at this bright blue, that's what you're going to get from the data table above. Okay, so everything is kind of color coordinated for you to have it make sense. So if you look at step number 2, the first thing you're going to do is this thing, measure your little triangle. The second thing you're going to do is lay out your runway. I would not have your runway like capture your car. Give it kind of maybe a centimeter or 2 on each side. To make your life easier, since you're measuring how far this car goes, right here, should I have 0 or 100 by my hand? 0, right? So 0 would make it a lot easier. Secondly, do you think I'm going to ask you to measure in inches or centimeters? Centimeters, right? So you're going to put it in centimeters, and make sure your 0 and 0 are facing your car. That way, if your car only goes that little bit, you know how many centimeters it was without having to flip it out or get out a ruler or anything like that. So that is your runway, and you want to try to make sure your car goes as straight as possible. You're going to start, I would suggest, you start with the smallest rubber bands. Here's the thing. Number 4, I know sounds silly to like literally tell you guys how to do a stopwatch, but especially with a small rubber band, it will go so quick that if you don't say 3, 2, 1, go, that like the 2 of you need to be coordinated. What's up?
Would we measure for the front tire or the back tire?
You're going to measure from the bumper. So the bumper is what should be right at the 0 mark, and then it's how far your bumper actually went, okay? So then, once you do number 4, you're going to repeat it 2 more times. So do me a favor, scroll down to data table number 1. So if you look at your smallest rubber bands, after each trial, you have to tell me how far it went in meters. So here's the thing. I just told you on this ruler you're measuring in what? Centimeters. So that means you got to do what to this number? Divided by... Think about how many cents are in $1? 100, right? So if it helps you in here, do me a favor right now. Put your cursor, right after meters. And in parentheses, put a little, whatever, like a little space. And then divide by 100, okay? So whatever you measure on your ruler, just divide it by 100. Your time is in seconds. So if I were you, I would just do your speeds right after you're done your trial. The mass is what we're going to do right now. So if you can do me a favor, this where my finger is the only green box on your data table. Once we convert it to kilograms, then we're going to change the color. So if I put this on here, so help me out guys, what should all these be at? 0, right? So, and I'm not trying to like be condescending, but some of you guys kind of forgot how to use one of these. So right now, should I move, does anyone really think this is over 100 grams? No, right? So let's start with a 10. So 10 is still sticking up here. So this car then is more or less than 10 grams. Okay. So now I take this up to 20. So now that is way too much. So now, there you go, take this back to 10. If I scoochy this little one just a little bit, scooch. And some of you guys are moving this so violently that it takes a long time. Yeah. The gentler you are, the easier it is. It's also very hard to do backwards. Is it lined up yet?
No. Ooh, kind of ish.
Oh, that's super close.
You're watching me sit up.
All right, so here's the thing. So now that they're all nice and lined up, can you read that? What that says? Where you are or not?
No.
Can you read it?
2.5.
So that says. So what's a better way than saying 2.5? 2.5. Okay. So 2.5 and what's in the back? 10. So 2.5 plus 10 gets you 12.5. So now do me a favor. Right where my cursor is, you're going to put 12.5. So now we got to turn that into kilograms. So you're going to take 12.5 and divided by 1,000. Because kilo means 1,000. So here's the thing. This one number that you have, is that going to change the same, or is it going to change at all throughout the lab? No. So do me a favor right now. In here, you're going to put 0.0125. Okay. That, whenever you put it down once, you can put it in the whole way down, okay? So literally right now, just paste it in the whole way down. It's not going to change. You're not going to be adding anything to your car. And then do me a favor, when you're done with that, look at your second data table. And same thing. You just paste it right in there. Sorry, it got kind of wackadoo when I get it in there. But literally, all I did was just paste it in there. So now, you're all good. I honestly didn't want to have a triple beam balance out and have all you guys worry about that too. 3, 6, 9, 12. 3, 4. All right, so help me out. If I have 24 of you in here, that means I'm going to have how many groups?
I am smart.
So here's the thing. I am going to ask that you guys, here's the deal. You're going to need your calculator. Right now, your book bags, can you take your book bags and put them underneath your lab table or your 10% of your entire grade in this course? So it seems almost silly to not get an easy 10% of your grade to be an easy A. So right now, look at the rest of your questions on your own sheet. You might want to ask yourself, have you turned in every single, or have you completed every single day? And did you write a complete sentence? Okay? Those are the things that I am mainly looking for when I grade your opening and closing questions. So right now, go back through, and honestly, I know some of you guys were struggling because Wednesdays when I didn't see you in person, but now that you saw me every day of the week, it should be a little bit easier. Today's opening question is the only one that is okay if it's not in complete sentences. Your ed puzzle, that I think more than half of you guys started yesterday, and I got 8 of you to turn it in already. I need that ed puzzle by midnight tonight. Same with this. When it says why we did not do this lab outside, what would have happened? I mean, yes, go ahead, Mars.
The ground isn't even.
There you go. So the ground isn't even. What else is true about that ground? It isn't even. Go ahead, Colton. What were you going to say? Go ahead. Okay, the wind would have definitely knocked it over. Go. Okay, so if I had to do it on the grass, it wouldn't have moved at all. What else? I would take any of those 3 reasons, all right? It wasn't flat. The ground is not flat. It's not smooth. Or the grass wouldn't have let the carpet move. I need one of those 3 reasons. Make sure you write it in a sentence. Make sure you hit submit. Guys, you are not leaving anywhere till 11 or 9, so just sit down, hang out, relax. You're not crowding by my door. Yeah. Yes.
It's a little bit of
Okay, double it.
No, there's no.
You're all right. Come on.
Damn.
Sandal.
Have a good day, guys. You said that right.